Recent discoveries didn't answer that question, they made it harder. Radio telescopes heard something, new images saw something, and none of it fits the standard picture. For weeks, scientists tried to force this object into normal comet physics, but the data keeps pushing back. Every time a new observation comes in, the mystery gets deeper. The first real twist appeared in late October, when a massive radio array in South Africa locked onto 3I Atlas and picked up something scientists did not expect. Narrow absorption lines at frequencies linked to hydroxyl molecules. And here's why that matters. Comets sometimes release gas that glows in radio wavelengths, but this wasn't glowing. It was absorbing. That means there's relatively cold gas sitting between a powerful background source and our telescopes, blocking part of the signal. It's physical proof that material is being released into space, and it tells researchers the molecules are real, not noise, not a glitch, not imagination. Even stranger, the Doppler shift of those lines matched the object's exact motion. In simple terms, the signal moved with the comet. Astronomers measured how fast the object was travelling, the angle it was moving across the sky, and compared it to the shift in the radio line. Everything lined up with almost uncomfortable precision. If this were just static dust or random background interference, the numbers wouldn't match. But they did. Perfectly. So now the scientific community has undeniable evidence. 3I, Atlas, isn't silent. It's active. It's releasing something into space. And the absorption profile even hints that the gas is colder than the background radiation behind it, which is exactly what you'd see if ices were breaking apart or sublimating off a solid surface. Still, half the mystery isn't what was detected, but how early it was detected. Atlas is unusually faint for the level of activity it's showing. Typical comets that release gas like this glow brighter and create obvious dust around them. Atlas didn't, at least not at first. That mismatch is what sparked the first wave of uncomfortable questions. If the object is shedding molecules, where's the bright debris cloud that should come with it? Scientists began to wonder, are we seeing tiny, controlled releases? Is the gas being ejected in specific directions? Or is this something entirely different? Something natural, but rare? Whatever the answer, the radio detection was the first crack in the normal comet storyline. It told researchers they were dealing with something active, physical, and measurable, just not measurable in the way comets usually behave. And the next discovery made the situation even stranger. Not long after the radio detection, astronomers tried something simple but clever. Instead of taking one long exposure of 3I as Astiles, they captured dozens of short frames and stacked them together to boost the faint details. That's when the second shock landed. The combined images revealed a glowing halo stretching almost 500,000 kilometers across, bigger than some planets, and laced through it were at least 7 narrow jets shooting outward from the object. And then came the detail that made scientists sit up. Some of those jets were pointing toward the sun. Normally sunlight pushes dust and gas away from a comet, forming tails that stretch in the opposite direction. But Atlas showed anti-tails jets firing against the pressure of radiation. To make matters even stranger, these jets weren't faint or subtle. They were sharp, distinct, and consistent across multiple stacked frames. Even observers working under terrible sky conditions, moonlight, twilight, haze, found the same structures. When bad conditions still produce the same clear result, you can't blame processing tricks or camera noise. It means the features are real. The brightness profile around the object added another twist. Instead of fading smoothly, the halo looked structured, almost layered, as if material was being released in repeated bursts. That suggests activity that's not random. Something was controlling the timing, the direction, or the intensity of the jets. Natural comets can behave like this, but it usually requires very specific surface patches or deep interior fractures, the kind you only see in unusually young or unstable objects. And 3C Atlas wasn't even in the most active part of its orbit anymore. It had already passed perihelion, the closest point to the sun, yet the jets were still firing. It's like watching a campfire burn hotter after the fuel should be running out. That alone forced astronomers to wonder what exactly was going on beneath the surface. At this point, researchers could no longer treat Atlas like a simple ice ball flying through space. Radio signals proved gas was there. The stacked images proved jets were active. But the biggest mystery was still ahead. Because while the object was spewing material into space, it wasn't slowing down. Actually, it was speeding up. Normally, a comet speeds up or slows down only because of gravity. But when researchers charted 3I Atlas's orbit, the numbers refused to sit still. Its trajectory didn't match the gravitational model. There was a small, steady push and extra acceleration, nudging the object off the path it should be following. When comets do this, it's usually because they're venting gas. Think of it like a natural rocket. Material shoots out one direction and the body moves slightly in the opposite direction. Easy to explain, but Atlas had a problem. If outgassing caused this much acceleration, the object should have dumped billions of tons of dust and vapor into space, enough to create a massive bright debris cloud that every observatory could see. Except that cloud wasn't there, not faint, not hidden, not buried in noise, it was simply missing. That leaves two possibilities. Either there's a natural process that gives you thrust without the giant plume we expect, or something is pushing this object in a controlled way, without blasting out a mountain of debris. The idea sounds dramatic, but the data force scientists to say it out loud. The motion of 3 Atlas doesn't fit the simple comet model, and the deeper they looked, the more the gaps widened. To be fair, there are natural theories that can stretch to cover parts of this behavior. Some comets have buried ice pockets that explode in sudden vents. Others have uneven surfaces that channel gas in strange directions. A fractured nucleus could shoot jets like nozzles and create thrust without releasing dust evenly. In rare cases, geometry and sunlight combine to create backward-facing anti-tails, even though it looks impossible. But here's the problem. Even the most creative natural models struggle to explain all of it at once. Jets firing after perihelion when activity should be dying. Absorption lines showing cold gas in front of a bright source. A gigantic, persistent halo with structure, not chaos. Acceleration with no massive cloud. You can get 1 or 2 of those in a standard comet. Getting all of them together? That's not common. And as the evidence kept stacking, the natural explanations started to feel like patchwork possible, but not clean. This is where the scientific conversation changed tone. Not in a sensational way, but in a cautious one. Because the natural answers kept getting weaker, some researchers argued that the technology explanation shouldn't be dismissed. Not confirmed, just kept on the table. The logic is simple. If something produces thrust without releasing enormous clouds of material, then tiny controlled jets similar to attitude control thrusters fit the bill. That would explain the direction of the jets, the steady acceleration, and the missing debris. No one is claiming proof, no one is shouting alien craft. The argument is scientific. You don't delete a hypothesis just because it's uncomfortable. You delete it when the data kills it. And so far, the data hasn't. And here's what makes this even more interesting. If the technological hypothesis is wrong, we still learn something extraordinary. Because then we've discovered a new type of natural comet physics that breaks the rules we thought we understood. Either outcome changes the story of 3I Atlas in a big way. But everything comes down to clearer data, and that's where the controversy starts. When the mystery deepened, everyone turned their attention to one thing: high-resolution images. And there's a reason. Ground telescopes can show halos and jets, but only a close-range camera can reveal the true shape of the object: smooth, rocky, fractured, or structured. We have a spacecraft that can do that. NASA's Mars Reconnaissance Orbiter. Its high-rise camera reportedly took close-range shots of 3I Atlas back in early October. The community expected those images to be released quickly. They weren't. Weeks passed, then a month. Researchers filed requests, astronomers sent emails, even members of Congress demanded answers. Still no release. Official statements blamed the delay on administrative backlogs and a recent government shutdown. But that explanation didn't calm anyone, not when the data could change everything. Those frames could show surface vents, repeating patterns, or even clear structural geometry. Instead, They're sitting unpublished. Meanwhile, the object moves farther away every day, and that distance makes new observations harder. It's not just curiosity at stake, this is time-sensitive science being slowed by paperwork. And while the public waits, the mystery only grows louder. But there's still one chance to break this open. In March of 2026, 3i Atlas will glide roughly 53 million kilometers past Jupiter, close enough for the Juno spacecraft to listen. Juno has a low-frequency dipole antenna designed to pick up radio waves in ranges that most Earth-based telescopes can't detect. The plan being discussed is simple. Point Juno at Atlas and scan for something coherent, something patterned, repeating, or intentional. If nothing unusual shows up, we learn it's probably just an extremely weird comet. Case closed. But if Juno detects anything beyond natural static, even a faint structured signal, then the debate becomes something else entirely. And Juno isn't the only option. Over 200 observatories are already tracking Atlas, and hundreds more are lining up to join. Radio networks, optical telescopes, and space-based sensors all watching the same target. For the first time, a mysterious interstellar object isn't slipping by unnoticed. This one is under a microscope. The question is whether the universe is ready to give us a straight answer. So here's where things stand. We have a visitor releasing molecules with a signature that matches its motion. We have a 500,000-kilometer halo and at least 7 jets firing in strange directions. We have a measurable acceleration that gravity can't explain, and no debris cloud to account for the thrust. We have high-resolution images that exist but aren't public. And we have a narrow window in 2026 where a spacecraft might catch a whisper of something hidden in the radio noise. None of this proves anything extraordinary. But it proves something even more important. The story isn't over. If the missing debris cloud suddenly appears, Atlas becomes the most active comet ever recorded. If it doesn't, and the acceleration continues, then the universe just handed us a question we've never been forced to answer. Either way, this is not a boring rock drifting through space. Something unusual is happening out there, and the next round of data could change how we see interstellar visitors forever. Natural or engineered? The truth will reveal itself soon enough, and the telescopes are already watching.